Hey, Mr. Harridan here. We're going to go over what is a mole for covalent and ionic.
I've been in this business a long time.
That's nice, Judge Judy. I've been in this business a long time too, just so you know. Yeah, I'm hanging out with Judge Judy today, just so you know.
I'm speaking. I'm here.
Yes, you are, Judge Judy. You are here. Okay, a mole is a counting number, okay? This should be review for you. Remember, it is 6.022 times 10 to the 23rd molecules for a covalent compound and 6.022 times 10 to the 23rd formal units for an ionic compound. This is what we call Avogadro's number. The molecular mass of a covalent compound, which is molecule, and the formal mass of an ionic compound represents the molar mass in grams of 1 mole of substance. Remember, these are the numbers that you look up on the periodic table and round them to 2 decimal places. Okay? So, for example, we have oxygen 2. We know the molar mass is 32.00 grams per mole down with the gangsters.
Just a second.
Yeah. Give you just a second, Judge Judy here. So here we go. Cyclononane. Hopefully you remember that nano is 9 carbons because this is a hydrocarbon. So we have to have C and H. And cyclo means you double the hydrogen. So this is 18. So then you have to do one of these things to find the molar mass, which is the same thing as molecular mass, because molecular mass is just for covalent compounds. You use your periodic table, you use your decimal numbers, which is your atomic masses. So you're doing 9 times 12.01, and you're doing 18 times 1.01. And I don't have these worked out ahead of time. Okay, so this is 108.09. This is 18.18. 100.809 plus 18.18 is 126.27 G/moles down with the gangsters.
Just let me ask the questions and try to give me just the answers that I need.
Okay, I'm working on it, Judge Judy. Okay, bromine, remember, is Br2. So we have to do Br2 times the molecular mass of bromine, which is 70.90. 2 times 79.90 is 159.80 G/mole. That is the molar mass of bromine. And I should probably write the substance after that one too. Okay. Okay. So hopefully we remember how to do that. Okay. Converting mass to moles and vice versa at the molecular mass. Okay, so here we're going from grams to moles or vice versa, right? You have to use the molar mass. So, for example here, Rufus measured out 79.83 grams of tetraphosphorus decaoxide for experiment. How many moles is this? So tetraphosphorus decaoxide is P4O10. Okay. We are starting off with 79.83 grams of that. We are trying to find the moles. Okay. So we are going to need a conversion factor. Put the scribble down here. Grams on the top, grams on the bottom. What are we going to convert to? Moles. Remember, our conversion factor for grams to moles is 1 mole equals the molar mass in grams. So we have to do P is 4 times 30.97. O is 10 times 16.00. 4 times 30.97 is 123.88. This is 160.00. So our molar mass should be 283.88 G/moles. Down with the gangsters.
Listen to me.
Okay, so 283.88 goes right here. And 1 mole goes right there. You multiply across, you divide. This number has 4 significant figures, so our answer should have 4 significant figures. So my answer is 0.2812 moles of P4O10. Okay. Okay, on to page 2.
Outrageous. Really?
Yeah, really. Okay. Still working on the review part of this here. So, if we have 4.7 moles of fluorine, how many grams of fluorine do we have? Fluorine is F2. It was one of the 7 diatomics here. So we are going to take 4.7 moles and we are going to convert that over to grams. So for moles to grams, again, we're going to use the conversion factor of 1 mole equals the molar mass in grams. So this time when I set up my conversion chart here, moles is on the top, moles goes on the bottom. What are we going to convert to? Grams. Swish, swish. You have to find the molar mass of fluorine. Fluorine has 2 times 19.00, which equals 38.00. G/moles. Down with the gangsters. The 38 goes on the top because that is the grams per 1 mole. This number has 2 significant figures, so my answer should have 2 significant figures, which is why the answer is going to be 180, no decimal point, because that has 2 significant figures, F2, or you're going to write 1.8 times 10 to the 2nd grams of F2. Same answer. Okay. Trailing zeros do not count with a decimal. So if I was to put a decimal on there, that would be 3 significant figures. Okay. So that's what we do. We're going from moles to grams or grams to moles. The next one here is when we're going from moles to molecules, atoms, or formula units. Okay. We are going to use the conversion factor 1 mole equals 6.022 times 10 to the 23rd here. So for this problem here, we have 0.00375 moles of carbon dioxide. We are trying to find the molecules. Okay. So this conversion factor we're going to use here is 1 mole equals 6.022 times 10 to the 23rd molecules. Okay. Moles is on the top. You have to put your moles on the bottom. What are you going to convert to? Molecules. Remember, the only number we use for moles is 1. Molecules, we're going to use 6.022 times 10 to the 23rd. And we end up multiplying those two numbers. And we get 2.26 times 10 to the 21st molecules of CO2. Because remember, you have to go swish, swish when you're doing this. Okay? Because I'm trying to get you set up for doing the 3-step problems. That's what I'm trying to do. Just so you know. Did I lose Judge Judy? Oh no. think I did. Maybe.
You
Nope.
see how easy that was?
Yeah, that was so easy, you know. Very, very easy. Okay. Next one here. We are starting off with 4.55 times 10 to the 24th molecules of propane, which is C3H8. We are going to convert that over to moles. So our conversion factor we have to use here, since this is a one-step problem, is 1 mole equals 6.022 times 10 to the 23rd molecules. Molecules on the top. You're going to put molecules on the bottom. What are we going to convert to? Moles. What number goes by moles? 1. What number goes by molecules? 6.022 times 10 to the 23rd. Remember, you have to use the E key to properly get the correct answer for this problem. So 4.55 second E 24 divided by 6.022 E 23, and we get 3 significant figures, so this answer is going to be 7.56 moles of C3H8. Okay? That is review over what we've gone over. Now, there's another conversion factor here that we have to learn here. There's for moles going to liters of ideal gas at STP. Yeah, you know me, ideal gas at STP. So this is going to be using, this is for moles to liters of gas at STP. Okay. The conversion factor here is going to be 1 mole equals 22.4 liters of ideal gas at STP. You can only use 22.4 liters for gases at STP. If it's a liquid, there's another method to use. Okay? This is only for gases and it has to be at STP. Okay, so example number 7 here. How many liters of propane gas at STP are present in 0.1458 moles of propane? Apparently I have a propane issue this problem set. So we are starting off with 1.458 moles of propane.
Had I been wrong? I was once wrong in 1947.
Wow, Judge Judy, you only wrong once since 1947, huh? It's pretty amazing. Okay. We are converting this over to liters. Okay? Moles on the top, moles on the bottom. What are we going to convert to? Liters. Swish, swish, right? The conversion factor we are using is 1 mole equals 22.4, or as I like to say, 22.4 liters. So we're going to put 22.4 here, and we're going to put 1 mole there. And I get 3.266 liters of propane. Propane's a gas at STP. This number have 4 significant figures, so this answer has 4 significant figures. Okay. How many moles of oxygen of difluorine gas are present at 3.5679 liters of oxygen difluoride at STP? So we are starting off with 3.5679 liters. We are going to moles. Okay. So liters is on the top, liters is on the bottom. What are we going to convert to? Moles. Okay. Our conversion factor here is 1 mole equals 22.4 liters. So this time 22.4 liters goes on the bottom. Swish, swish. 1 mole goes on top. And we divide. And you type in the numbers correctly, Mr. Harridan. This has 5 significant figures, so the answer to this is going to be 0.15928 moles. Okay? So the summary conversion factor sometimes you'll hear me in future videos refer to this as the tape. These are the conversion factors I'm using when I am doing the tape. 1 mole equals the molar mass in grams, which equals 6.022 times 10 to the 23rd atoms, molecules, and formula units, which equals 22.4 liters of gas at STP. Eventually, I'm going to teach you how to do reaction stoichiometry, where if we're going to start at the tape and then we have to use the reaction and then we're going to use the tape. So these are the conversion factors I am referring to, which I just went over in the video I just did. Okay? You guys are champions. The legend is out. And I should probably label this OF2 at STP. Yeah, that'd be great. Good job there, Mr. Harridan.